Good morning, everyone. So, in today's class, we are going to talk about theory of logarithm. And when we talk about theory of logarithm, we are as well talking about the reverse version of the laws of indices. And just so you know, like in indices, we have whenever there's multiplication operation between them, we add the powers. But in logarithm, whenever you have addition operation between them, provided that the base are equal, then you will what? You will add the numbers. So let's go. Log A base C plus log B base C. Before that, let me explain something. Now, whenever you have this shows that what? This is the base in which the log is being expressed. And whenever you have this, it shows that what? This is the log of the number to the log you want to actually find. So let's say whenever I have log A and I didn't represent any base, meaning that I'm adding the base to be what? In base 10, because it's a natural log. Naturally, counting numbers are in base 10. Naturally, counting numbers are in base 10. So, which simply means that here there is what? There is base 10. Which simply means that whenever you have a question, peradventure you are given a question log 2, and natural log of 2 is actually what? 0.3010. So, which simply means it's what? It's in base 10. But then, whenever you are given a question that is not supposed to be mirrored in what? In a natural log base, it's the base will be given. And that's why I spelled this out to be what? Log A base C, log B base C. Now, if you have something like this, you actually what? Going to multiply the numbers, and it implies you will take log of a base, then you will what? You will multiply the numbers. A multiplied by what? By B. Then what you have, let's take for example, log 2 base 10 plus log 5 base 10. Then what you have there is what? Log base 10 into 2 multiplied by 5. 2 multiplied by 5. Then simply you have log 10 base 10. Now, this is not the final answer, mind you. We are still going to provide a final answer in the subsequent what? Laws we'll do. I think the law 3. So, the second law, that's what? Log A base C minus log B base C. Now, whenever you have negative sign, you what? You divide, provided that the what? That the base are what? Are the same. The base are the same, and that is take a single log of a base, then what? Then divide the numbers. So a typical example, that's log 100 to base 2 minus log 50 to base 2. It implies that take a log of a base, then what? Then divide 100 divided by 50. The final answer is what? So the answer is rather 2 base 2. We have log of a number to the same base. Here also we have log of a number to the same base. Then log 3 stays at what? Whenever you have log of a number to its base, then you said it's what? It is 1. So which simply means that what? Log of a number to that same base is what? Is 1. Here also is 1. That is, we've gotten our final answer on different bases. So now we are going to talk about what? The fourth law. We are going to talk about the fourth law. And talking about the fourth law, let's rub this. Talking about the fourth law, that's what? Power law. So whenever I have this log m raised to power p base c, is just saying that whenever you have a log of a number expressed to a certain power, then you need to what? You need to bring the power behind and multiply the log and the base. Are we together? A typical example is what? Log 81 base 3. The first question you should ask yourself is, can 81 be expressed in the base of 3? Definitely yes. And that's why you need to be versed when knowing all these powers. Like 3 raised power 1, you can learn it to 3 raised power 6. So, and that's 729. 3 raised power 1, 3, 3 raised power 2, 9, 3 raised power 3, 27, 3 raised power 4, 81, 3 raised power 5, 243, 3 raised power 6, 729. You can learn it because it will really help and it will help your thinking process. So now I know that 81 is what? 3 raised power 4 and this. So which simply means that what? If I'm rewriting, I'm saying 4 multiplied by what? Log 3 base 3, which makes it very simple because I have log m base m equals to 1. So here your final answer is what? 4. Here your final answer is what? 4. Then let's talk about when the base is at when the base is now carrying what? The power. When the base, so when the base is now carrying the power, when the base is carrying the power, it comes to different things because when the number was carrying the power, we just did that log m base c, we multiply what? P directly. But then when the base is carrying the power, we say it is what? Inverse of that what? Of that power, we now multiply log m base c. That's the inverse of that power that will multiply log m base c. And that is what? A typical example is, let's say you have log 2 base 32. Apparently, you know that the number is what? Is lesser and the base is bigger. Applying this law, we say that what? Can 32 be expressed in the power of 2? Definitely yes. That should be what? One of your thinking. Now, since we've established that what? 32 can be expressed in the power of 2, then we do it. So 32, what raised power 2 can give you what? 2 raised power 1 will give you 32. That's 2 raised power 5. So 2. Then you say what? You say 1 over 5 times log 2 base 2. Then you say 1 over 5 times 1. Your final answer is what? 1 over 5. Are we together? Your final answer is 1 over 5. So let's quickly talk about what? Change of base. Now, when we're talking about what? Change of. Now, we said we're talking about what? The change of base. The change of base. Now, when we're talking about change of base, this is log A base C, and I just want to split them. Peradventure, I'm given a question that naturally I don't have answers to. But then I can try method of splitting based on what? On the parameters given, or based on the given what? On the given parameters rather. So now log A splitting 2 divided by what? Log C. What I introduced there is what? The natural log. What I simply introduce here is what? Is the natural log. That is splitting log A, attach the natural log, splitting log C to base 10, log A to base 10, log C to base 10. A typical example is given log 2 base 10 to be what? 0.3010 and log 3 base 10 to be what? 0.4771. So now, you said we should what? We should evaluate log what? Log 8 base 9. Now, it tells us to evaluate log 8 base 9. Now, telling us to evaluate log 8 base 9, we just need to think that how do I achieve this? Now, we've said we can split it. Even after I said log 8 base 10, log 9 base 10, what else do I do? But then let's move first. So log 8 base 10 divided by what? Log 9 base 10. Then, can I since is what? Log 2 that I'm given and log 3. The question goes thus. Can I express 8 in the power of 2? Definitely yes. Can I express 9 in the power of 3? Definitely yes. So that's 2 raised power 3 base 10 over log 3 raised power 2 base 10. So that's now. What we are going to do next is to what? To apply the fourth law, which says that whenever log of a number has a power, you will say 3 multiplied by what? Log 2 base 10. And this will now be what? 2 multiplied by what? Log 3 base 10. Then we say what? 3 times 0.3010 over 2 times 0.4771, which is equals to 0.9030 over 0. What? That's 2 times 1, that's 2. So 2 times 7, that's 14. 4 carry 1. 2 times 7, 14 plus that one, 15. So carry 1. 2 times this, that's 8 plus that one, that's 9. So are we together? So here we are just going to say, okay, 0. This divided by what? Divided by 0.9542, and that gives us what? Our final answer. So the second part of the change of base goes thus. Okay, now let's say I have that same log A base C. Now, if I take the inverse of this log, if I take the inverse of this log, then the base changes. Then the base changes automatically. Are we getting it now? Now, if I say 1 over, are we together? So 1 over, then I say log C base A. Are we together? So let's take an example, log 2 base 32. Know that we made this example earlier when we were talking about when the base carry power. We make use of this example. We are going to make use of the same example so as we can know whether we'll arrive at the same answer. So now you take the inverse, that's log 32 base 2. And in that sense, can 2 be in powers of, can 32 be raised in the power of 2? Yes. So that's what? Log 2 raised power 5. Now, we said whenever we have the power, then it will multiply the log of its number to its base. And log of its number to its base, we establish is what? Is 1. So that's 1 over 5 times 1. The final answer is what? 1 over 5. So having established this, so we have actually exhausted the theories under logarithm. Then we can as well say that they are simple equation, although not simple equations, but then from simple equations involving logarithm, we can now move to equation leading to maybe simultaneous equation or quadratic equation dealing with what? The theory of logarithm. So saying that, we can as well take an example. Okay, let's quickly make an example. Okay, equation involving logarithm. So now, for example, let's say example 1. Let's say log x base 5 equals to, let's say log x base 5 equals to 3. Now, you are told to what? To find x. Now, you're told to find x in this equation. Now, what the question keeps mirroring is that, now, what number are you going to put to the base of 5 that will give you 3? Now, it's simple and it's not. Although, we can now say that, for example, solution. Now, for this to be easily simplified, for the log to disappear, this base will come here, which, so I said this 5 will come to what? To be the base. Is a base here, but in index form, it will come to be the base, and this 3 will be the power. So it goes thus. X will now be 5 being the base, 3 being the power. So it means that x equals to 5 multiplied by 5 multiplied by 5, and x equals to what? 1, 2, 5. So that's just the simplest way we can as well what? Express, the simplest way we can as well express what? Express logarithm equation. So let's say example 2, log x plus 2 base 2 equals to 4. Now, in this aspect, what we did earlier is the exact same thing we will do. So this base here comes here and be the base. So which means x plus 2 will be equals to what? 2 raised power 4. And x plus 2 equals to what? 16. What you need to do is just to what? To collect like terms. To collect like terms. And x plus 2 equals to what? X, okay, x plus 2. When plus 2 cross equality sign, it should now be what? Minus 2. So x equals to what? 16 minus 2. X equals to 14. So we can see that those are the equation, but then there are still some equations that are more complex. Okay, there are still some equations that are more what? That are more complex. Let's say x log x squared plus 3 log x squared plus 3 equals to, so base 2 equals to what? So equals to 19. Okay, oh, sorry. So equals to let's say equals to 4. Now, in this case, just so you know, 3 raised power, what's it called? So now x squared plus 3 equals to what? 2 raised to the power of 4. So x squared plus 3 equals to 16. Then we collect like terms. So x squared equals to 16 minus 3. So x squared equals to 13. Are we together? X squared equals to 13. Now, we need to what? We need to find the root of both sides. So, as far as this equation is concerned, the answer to what? To the value of x is what? Root 13. So, the next example we're going to deal with is actually a WAEC question 2008. So, WAEC question 2008, and it goes thus: 2 log x minus log 1 minus x equals to log 2 minus x. Are we together? Equals to log 2 minus x. Now, the question tells us to what? To find x. Now, simply, we are going to take it bit by bit. Now, in earlier said logarithmic laws, I said whenever you have a number behind, it shows that what? It is the power. Just for reminder, what we did here. I said whenever you have this, you bring the number back. P times log m base c. We remember. So from here, this is what we want to achieve. So we can go from here, or from here. We can either go either ways. So that's what we want to do. Which means in this method, it can as well what? Be in this format. So that's the next move. So that's log x raised power 2. All are in what? Base 10. So we're not bothered about that. 1 minus x equals to log 2 minus x. Now, negative means what? Division. So take one of the log, x squared as the numerator, 1 minus x as the denominator, equals to log 2 minus x. Now, whenever you have a log at the right hand side in logarithmic equation, whenever you have a log at the right hand side and you have another log at the left hand side, what you need to do is to what? Is to eliminate them, provided they are in the same base. So we have x squared 1 minus x equals to what? So 2 minus x. Then we can now what? Cross multiply. So then we can what? We can cross multiply. Haven't gotten this to this stage. Then let's rub this so that we can use a plain place. So now that's x squared equals 1 minus x multiplied by what? 2 minus x. So what we need to do is just to open the bracket. So x squared right hand side, 1 times 2, 2, 1 times minus, okay, let's expand. 1 into, this one we multiply this 2 minus x. So this minus x also we multiply 2 minus x. So x squared equals to, let's open the bracket, 1 times 2, 2, 1 times minus x, minus x times 2 minus 2x, minus times minus plus x times x squared. Are we together? So x squared here equals to what? 2 minus x minus 2x. That's minus 3x. You are owing someone 1 naira. You are owing another person 1 naira. How much are you owing altogether? That's 3 naira. You remember those kind of relativity then when we're still way more younger. So now, this cancel this. Then we have 0 equals to 2 minus 3x. Then collect like 10. Minus 3x cross equality sign. That's 3x equals to 2. Divide both sides by 3. So final answer, x equals to 2 over 3. That's our final answer. We can see that all these questions, it's not as though they are very hard like that, but then you just need to understand them and what? And solve them carefully. You need to understand them and solve them carefully. So the next equation we are going to solve now is logarithmic equation leading to simultaneous equation. At least after that, we know that we are done with what? With logarithm, except we want to deal with other examples. And further examples are okay. Now, we've seen that this is actually the solution he gave us. So now we're moving to the next question. So log x minus 2 base 7 plus log x plus 3 base 7 equals to log 14 base 7. Now, haven't gotten all of this. Now, what you need to do is just for us to steadily follow the law. Positive says that we will multiply the numbers since the base are what? Equal. Now, x minus 2, x plus 3 base 7 equals log 14 base 7. Now, I said once you have a log of a base at the right hand side and you have the log of that same base at the left hand side, it cancels each other. So then we have x minus 2, x plus 3 equals to what? 14. Then we can what? We can expand. This one, we can split this to multiply this. X multiply x plus 3. This minus 2 multiply what? X plus 3 also. That's equals to 14. So x times x, x squared. X times 3, 3x. Minus 2 times x, minus 2x. Minus 2 times plus 3, that's what? Minus 6 equals to 14. Now, x squared plus 3x minus 2x, that's just x. So bring 14 inside, minus 6 minus 14, that's what? Equals to 0. Then we say x squared plus x minus 6 minus 14, that's minus 20, equals to 0. Now, it brings us to, let me rub this so we can freely what? Solve that quadratic equation. Now, that's the beauty of logarithm equation. Now, this one leads us to what? Quadratic equation. Then we'll be thinking of numbers. We think of two numbers that, now, normally, if we want to use factorization method, there are methods of solving quadratic equation. Factorization method, quadratic formula, and how do I put it? Completing the square method. But then, the method we want to use here is just factorization method. Are we together? So, now, what we need to pay attention is how we will split this so that we will get, because we can only factorize in twos, maybe 2 things, 4 things, then we group them. In 4, we will group them 2, 2. Now, how can we split this? We think of 2 numbers that when we add, it will give us this. And when we multiply, it will give us what? minus 20x squared. That's x squared times minus 20. So that's minus 20x squared. That is, when we add, it will give us plus x, and when we multiply, it will give us minus 20x squared. It's not far-fetched. That's plus 5x minus 4x, because 5 times 4 gives us 20, plus times minus give us minus, plus 5 minus 4 give us what? Plus. So which means we'll say x squared plus 5x minus 4x minus 20 equals 0. Then we say we group this, we group this. Now, here, what is common? That's x is common. When you factorize s out, it will remain x here, then 5 is left alone, plus 5 is left alone. Here, minus is common, write that first. Now, 4 can go in 20, so 4 is what? Is common. Then here you are left with what? X. Then repeat what you have here. If you factorize correctly, just repeat what you have in the brackets here. Then let's try. Minus 4 times x minus 4x. Minus 4 times plus 5 minus 20. We are correct. So then group it. X minus 4, then x plus 5. So we have it to be x minus 4 equals to 0, or x plus 5 equals 0. So x minus 4, x equals to 4, or minus 5. So therefore, our answer here is what? 4 minus 2. That's what? 2. 4 plus 3, that's 7. 2 times 7, that's 14. We get our answer, right? So, which means our answer will be what? Will be positive. Our answer will either be what? Positive 4 or negative 5. Positive 4 or negative 5. That's our what? Our answer. So, next, let's solve another equation leading to simultaneous equation. Let me rub this. Leading to simultaneous equation. So, leading to simultaneous equation. Okay. Now, our last example for the day. Let's say 6 log x base 3. 6 log x base 3 plus 2 log y base 3 equals to 7. Now, 2 log x base 3 plus 4 log y base 3 equals to 9. Now, given this kind of equation, then what comes to your mind is, what can I do? We have log x base 3, log x base 3, log y base 3, log y base 3. So, these things are very easy. Just what? Represent log x base 3 with a letter. Represent with a variable rather. Represent log y base 3 with a variable. So, let log x base 3 equals to a and log y base 3 equals to b. So, which means here I will just say 6a plus 2b equals to 7. Equation 1. We've gotten the first equation. Then, since we'll just say the second equation is 2a plus what? Plus 4b equals to 9. That's equation 2. Then, this is equation 2. Then we need to what? To solve simultaneously. Now, I've said in the previous classes we have that we have methods of solving simultaneous equation, which is substitution method, elimination method, or graphical method. But here, I think it's best for us to use elimination method. And let's eliminate B. Are we together? So, but first thing first, we need to be sure that these things are what? Are balanced. The coefficients in both equations are what? Are balanced. Now, coefficient of B in equation 2 is 4. In equation 1 is 2. So we just interchange it. We make it balanced. Multiply this by 2 and multiply this by what? By 1. Just for this to be balanced, because 2 times 2 will give you 4. 4 times 1 will give you 4. It will still maintain it. So 6 times 2, this 12a plus 4b equals to 14. So this is equation 3. Now, this next one, we can say it is what? 2a plus 4b equals to what? 9. It still retains what? Equation 2. Are we together? So now we can now eliminate. Now, for we to eliminate b, let me rub this. So for we to eliminate b, then we consider that they are having what? Similar sign. As they are having similar sign, we can eliminate. If they have similar sign, we will subtract. If they are not having similar sign, we will what? We will add. But they are having similar sign. So we can say subtract equation 2 from equation 3. Are we together? In this, that is, you are taking away the smaller one from the bigger one. So 12a minus 2a plus 4b minus 4b equals to 14 minus 9. So this is 10a. 10a, this cancel. So 14 minus 9. So 14 minus 9, that's 5. So divide both sides by 10. So a equals to 1 over 2. Now, a equals 1 over 2. Put a equals 1 over 2 in any of the equation. Let's say equation 1. In equation 1. So, here, this is it. Anywhere you see a in equation 1, that you put what? You put 1 over 2. So, 6 into 1 over 2 plus 2b equals to 7. 2 here 1, 2 here 3. So, let's rub this. Okay. Now, then we say what? Then we say 3 plus 2b equals to 7. Let's collect like 10. 2b equals to 7 minus 3. Because if 3 cross qualifying to be minus, so 2b equals to 4. So divide both sides by 2. So b equals to what? B equals to 2. Now, we can now say, now initially we said log what? X base 3 should be a, and log y base 3 should be what? Should be b. So now, our final answer, we want to get our x and y. Mind you, that was what the question said we should find. We should find x and we should find y. So x equals to half, then y abi equals to 2. So just so you know, the base here will become the base in index form. The base, so we say x equals to what? 3 raised power what? Half. and y equals to 3 raised power 2. So therefore, x equals to root 3 and y equals to 9. That's our final answer. That's our final answer. And with this, we round up theory of logarithm. Everything about logarithm, this is it. So I wish you well, and try to subscribe to our YouTube channel. And mind you, there are more videos coming up. We are going to be talking about SWORD, AP and GP, and the likes. Thank you for watching.